About half of a ppm of the Earth's crust is made out of mercury. Most of it's in the form of rocks.
It becomes a problem when it's released into the atmosphere.
For many years, scientists wanted to learn more about the global issue of mercury pollution, especially its environmental and human health effects. What was missing was an ultra-sensitive tool to continuously monitor the various types of mercury emissions in the air, at their source, and where they settle. Inventors Daniel Schneeberger and Frank Schaedlich answered the call with a series of innovative instruments. Schaedlich and Schneeberger, co-recipients of a $10,000 Manning Innovation Award.
Mercury is a global problem, and the reason for that is because it can be emitted from one continent or one country. It then can go up into the atmosphere, travel long distances.
And it'll deposit into snow, in rain, and at that point, when the snow melts, it can get into the biosystem.
Governments around the world realize that mercury is a problem, and they want to control emissions, but they do need the tools to be able to get the data so that they can make intelligent regulation.
There were ways of measuring mercury in ambient air, but it involved taking 6-hour measurements, taking those cartridges back to a lab, and so we developed an instrument that could work continuously in remote locations and give you a mercury reading every few minutes.
This is a patented cartridge, and it is responsible for amalgamating or trapping very tiny amounts of mercury.
We pass a known amount of air over this gold cartridge, and all of the mercury that happens to be in the air gets trapped on the cartridge. So we flush the cartridge with a carrier gas, heat up the cartridge until it gets red hot. All of the mercury comes out at once, and it goes into a detector, which is simply an ultraviolet light that we shine at the mercury. The mercury fluoresces, it gives off a glow.
And you essentially measure the light coming from that fluorescence detector, and that will tell you how much mercury was in that air sample. And this is the very heart of what makes this innovation work.
Our initial customers were the researchers. Then regulators, governments started buying our product. And then what happened is people started asking us if we could measure mercury in power plant stack gas. And we eventually came up with this. This is part of the system. And this is a way of measuring mercury in coal-fired power plant gas.
Starting January 2009, US EPA has enacted regulation that all coal-fired generating stations will have to comply with. Presently, there's approximately 1,000 smokestacks that will have to comply with this US EPA regulation, and we did produce the instrumentation that makes that possible. So the net result of this will be a reduction in mercury emission from these sources.
I think one of the most important contributions that our innovations have made is that it's allowed a much better fundamental understanding of how mercury behaves and how it travels from country to country. That increased understanding is the first step that's required for the reduction of mercury emissions worldwide.
And that's a benefit to all of us.
We were quite gratified to win the Manning Innovation Award. It was great to realize that somebody outside our small mercury research community thought we'd done something worthwhile.
It is exciting. Strangely enough, to researchers, we get excited as well.